Friends, in today's session, we are going to discuss on a topic support reactions. That is here we are going to solve one problem, that is complex problem is there. So at the end of this particular session, you will be able to solve the problem on support reactions, how we can calculate the reactions if the complexity is there in a problem. We begin with the problem. Find the support reaction for given problem or your beam is there. So the nature of the beam, it looks like in this way. We are considering here hinge. Next one, we are considering here the roller support. Next one, a lot of properties are there regarding the beam. That's we are considering here. This is your A, this is B, joint C, and D is there. Further, they have mentioned additional 10 kilonewton force. Then at a particular distance, inclined point load is there having inclination 45 degree, and the next one, the intensity of that force is 12 kilonewton. Similarly, they have mentioned here one UDL is there, and the intensity of that UDL is 3 kilonewton per meter is there. Further, they have mentioned another one, that is the couple, and the intensity of that couple is 4 kilonewton per meter. We identify the distances. So they have mentioned here the distances also. This is 2 meter, this is 1 meter. Similarly, 1 meter, 1 meter, 2 meter. So the remaining this particular distances they have considered. .5 meter, here also 1.5 meter is there. Our task is to identify the support reactions at node A and at node D is there. So first step that we are going to apply here. Before that, I am converting this UDL into point load. I am showing the details. So the span of the UDL is 2 meter. UDL, whenever we are converting UDL into point load, so 3 into 2, that is 6 kilonewton. The intensity is there, and the distance is 1 meter and 1 meter we are considering. We are bifurcating it. We are showing the point loads, means we are replacing this particular joints. This is the hinge support. So one is VA, and in a horizontal direction one, that is HA. These two, the reactions are present, normal reactions. Next one here, the roller support is present, only one reaction is there, that is your RA. We begin with the finding the support reactions for the given problem statement. So the first step we are considering here, that is evaluate the support reaction evaluate the support reaction. So here we are considering summation of moment at point A is equal to 0. Any one point you may consider, either A or either point D is there. Before that, I am considering here two components for incline. One is horizontal component, that is cos, vertical component, that is sine. So cos and sine. We begin with the further step. So at A, if I consider the movement center, so HA and VA, the both terms are 0. HA into 0 plus VA into 0. Next one, I am considering 10 kiloton force. It moves in a right hand side. It creates clockwise rotary effects, and the vertical distance they have mentioned here, it's 2 plus 1, 3 is there. So 10 into 3 next, plus 10 into 3. Now you may consider force horizontal, it is present here. So 12 cos 45 is there. So it moves in a left hand side, and according to this particular point it creates negative. So minus is there. So I am considering first here, that is minus, the force is 12 cos 45 and the distance. So this is the vertical distance. So total 3 is there. Similarly, you may consider vertical force, that is we have already resolved. 12 sine 45 is there. 12 sine 45 is present here. So this is 1 meter distance and remaining is 1.5. So you may consider it moves in a downward direction, so create clockwise plus 12 sine 45 into, now the distance is, we want this distance 1.5 plus 1, that is 2.5. Further 3 kilonewton per meter we have converted, that is 6 kilonewton is there now here. This 6 into the total distance 1.5 plus 1 2.5 plus 1 3.5 plus 1 4.5 is there. So here also it moves in a downward direction. So we have considered the positive sign, creates clockwise rotary effects, plus 6 into 4.5. Couple is present clockwise plus 4, and here it moves in upward direction and we want total horizontal distance. So minus RA into the horizontal distance. So 2, 3, 4, 5, 6, 7 is there. So minus RA into 7 is equal to 0. So let's do the calculation, find out the value of RA. So this is not RA, this is your RD is there. So we are considering RD. So it comes, how much it is? It comes near about 8.108 kilonewton is there. Similarly, we are going to calculate the remaining unknowns. How we can calculate the remaining unknowns? So first one, we are considering summation V is equal to 0. How many vertical forces are present? One is VA, second one is RD, third one is 12 sine 45 is there, and 6 kilonewton is there. So upward forces positive, VA plus RD is equal to 12 sine 45, next one plus 6. So you may calculate the answers, put the value of RD, already you have calculated here, that 8.108 So VA 8.108 is equal to 12 sine 45 plus 6. So do the calculation. So the value of V8 comes 6.377 kilonewton is there. Similarly, we are calculating now horizontal forces. So we are considering here summation H is equal to 0. How many horizontal forces are present? One is minus 12 cos 45 plus 10. Another one force is present here. You may consider HA is there. So HA first, right hand side positive. Then the next one value 10 kilonewton, right hand side positive, minus 12, it moves in a left hand side. So 12 cos 45 equated to 0. Now you may identify the values present here. So HA it comes 1.5 kilonewton negative. Like this easily we can calculate the unknown forces. So to prepare this video I have referred, these are the references. Thank you.